Hello everyone, this is Prashanth. Let's continue with the last lecture. That is, in last lecture, just we have discussed about IoT system management with network configuration, net network configuration. So, what are the requirements of IoT system management, and what is the network configuration? What are the applications? What are the applications, futures, so some real-time programming models that we discussed in the last class. So IoT system management having 11 types of models, some system manager, system task, communication API, like that we have 11 types of IoT system management steps are available in system black diagram of IoT system management. So these are the things already discussed in the last class. Now we are entering into the another extension of network configuration model, that is SNMP. SNMP. SNMP stands for Simple Network Management Protocol. So this is one of the protocol in order to establish network. So here this is the introduction of SNMP, Simple Network Management Protocol. So SNMP, what is first? Before entering into the main architecture of SNMP, first we have to introduce the what is Simple Network Management Protocol. So it is a framework used for managing devices on the internet. So it is first, basically it is called, it is act as a one framework. So it is the domain, it is one framework used for managing the devices on the available internet. So it provides a set of operations like get, put, delete, like that, some operations, set of operations for monitoring and managing the internet. So just our agenda is, in order to monitor the devices, compulsory to manage, we have to do some operations, or we have to know the some operations like put, get the value. So in order to provide set of operations for monitoring and managing the internet. So the Simple Network Management Protocol is a standardized protocol that facilitates the exchange of management information between the network devices and the central management station. So here the communication is going on in between here network devices and the central management system. So network devices, available networks, available devices in the network. So central management system, it can control all the devices at a certain point, that is central management station. So basically it depends on three factors. The SNMP, it operates client server model. So just it can send the request from the client, so it can receive the request and pass the response according to the requirement. So client server model, where the managed devices such as routers, switches, servers are the servers, and the management station is the client. So these are the some significant main significance of Simple Network Management Protocol. Three points here. So this is the Simple Network Management Protocol diagram here. So here there is an involvement of manager, SNMP manager, through the SNMP. So here under agents we have different parameter, router, servers, and multi-layer switch. Under SNMP agents we have different roles. Next, so this is normal network diagram of Simple Network Management Protocol. So here this is the introduction point of Simple Network Management Protocol. So here, in order to manage devices over the internet, so we have to maintain some protocols with port numbers. So here the process request to, the first process is request recipient by the agent, that is the which protocol it is used to request a recipient from the agent. So here UDP, UDP stands for User Datagram Protocol. Here the port number is 161. Next, managers communication with the agent. So the protocol is UDP User Datagram Protocol, same port number also 161. Next, notification recipient by the manager. So that is under UDP and User Datagram Protocol. The port number is 162. Just a little bit variation in the port number. Next, agents notification generation, that is under UDP, same User Datagram Protocol. That is available, any available port available in the network that can alert it to the agents notification generation under port number. Next, request recipient by the another protocol here, TLS or DLTS. So TLS datagram transport layer security. Transport layer security here, that is TLS or DTLS. So the port number comes 10161. Next, notification request. So it is request, it is notification. So under transport layer or datagram transport layer security, that is comes under port number of 10162. So these are the some protocols through the simple network management protocol with function and port number. Next, what are the main components? So on based on the diagram we discussed in the last slide, the first slide, we have some components. So the main components are SNMP manager, SNMP agent, and management information base. So here, what is manager, what is agent, what is management information base here. So let's we discuss very clearly manner. So SNMP manager. So manager, generally the manager, it manage all the performance or all the activities under the manager. So the same definition will also here. It is a centralized system. So we already know centralized system means what. So it can manage all the networks or devices under at a single point here. It is a centralized system used to monitor the network. It is also known as network management station. So it is known as the SNMP manager is also known as network management station. A router that runs the SNMP manager server program is called an agent. So while a host that runs the SNMP client program is called a manager. So this is the regarding the points regarding SNMP manager. So generally it is a centralized system. It can all the activities that can done by the client. Next, to SNMP agent. What is agent? It is a software management software module installed on a managed device. So the manager accesses the value stored in the database when we request. For example, www.iare.ac.in. So just before entering into this website, so just you can type www.iare.ac.in. Don't enter onto the don't press on the enter. So just when you enter on the enter button, so the service request sent to the server. So the manager access the values stored in the database. Where is the agent's information data? So the server can fetches the data from this source. So whether the IARE.ac information is available or not. So then it will quickly send back to the client. So to ascertain if the router is congested or not. So for instance, the manager can examine the relevant variable that a router stores, such as the quantity of packets received or transmitted. So this is the just one example. So these are the performance of SNMP agent after manager. So SNMP manager, SNMP agent. Next is MIB. Shortly, it is called MIB, Management Information Base. So here it consists of some information on resources that are not to be managed. This information is organized hierarchically. So the main, it having some information in terms of various parameters. The information is organized hierarchical. So it consists of objects, instances which are essentially variables. A MIB or collection of all the objects under management by the manager is unique to each agent system interface address installation IP or UDP or EGP, ICMP. So these are the some types of levels, 8 categories of MIP. So here system interface, address translation, IP, 4, 5, 6, 7, 8. So these are the 8 categories of makeup of management information base. So next, the main object is to home this group. So these are the three components of SNMP, Simple Network Management Protocol: SNMP Manager, SNMP Agent, SNMP Management Information Base. So this is the black diagram and with explanation. So here, what is SNMP concept? So the SNMP, the manager is a host that control the monitor the set of agents such as routers. So it is an application layer protocol. So which type of layer anybody can ask you? SNMP is a which type of layer protocol? It is application layer protocol here, in which a few manager stations can handle the set of agents. The protocol designed at the application level can monitor the devices made by different manufacturers and install on different physical network. So it is used in a heterogeneous network made up of different LANs and WANs connected by the routers or gateways. So this is the concept of SNMP. SNMP. So manager through the TCP/IP protocol, it can connect to the agent. So under agent, we have different agent variables like discussed in the last slide. So address translation, UDP, UGP, ICM, like that we have 8 types of MIB management information base. So this is the concept of simple network management protocol. Next to management components. So here the MIB having different components here. So the management is not achieved only through the SNMP protocol, but also the user use the other protocols that can cooperate within the SNMP protocol. So the management is achieved through the use of the two protocols here. The main SMI structure of management information. The second one, SNMP and MIB. These two are the two protocols under the management components. So it is a combination of SMI, MIBR, SNMP. All these three protocols and abstract notation one, that is ASN.1, basic encoding rules of basic encoding rules B. So here SMI, MIB and SNMP again. So here these are the three components under management components. SMI, structure of management information based simple network management protocol. So next, what is SMI, what is MIB, what is what? So here the structure of management information SMI here. So it is a component that is used in network management. So it's the main function is to define the type of data that can be stored in an object and to show how to encode the data for the transmission over the network. So the main function of structure of management information here, the to define the types of data, which type of data, whether the symbols or whether the pictures or whether the special symbols or whether the functional keys, whatever the data it contain, type of data that can be stored in an object and to show the how to encode and data for transmission over the network. So that is the main function of SMA, that is structure of management information. So it can define the structure, how can the data how much of data in terms of data it can be transmitted through the network. Next to the MIB, management information base is the second component of the network management. Each agent has its own MIB, which is a collection of all the objects that the manager can manage. So MIB is categorized into 8 groups. we already know system interface, address translation, IP, ICMP, TC, system interface, address translation, IP, ICMP, TCP, UDP, user datagram protocol, and the last one EGP. 1, 2, 3, 4, 5, 6, 7, 8. So these are the main 8 groups of under management information base system information address translation interface like we have. So these are the some points regarding SMI and MIP. So here SNMP defines 5 types of messages here. One is the get request, get next request, get request, get next request, set request, after request, getting response, next track. So here these 5 types of messages defined by simple network management protocol. Here SNMP manager under client, so this is agent under server. So here it is connection, get request to get response, get next request to get response, set request to get response, and trap. So these are the some just 5 types of messages under simple network management protocol. Next, what is request, what is response, what is trap, what is inform request? Here just one by one. What is get request? It is simply used to retrieve the data from the SNMP agents. In response to this, the SNMP agents responds with the requested value through the response message. So this is about the first message, that is get request. Next, to get next request. So to get the value of a variable, the manager sends the data to the next get next request message. The values of the entries in a table are retrieved using the kind of the communication. So this is the about the second message, that is get next request. The third one, set request. In order to set, to study by the SNMP manager to set the value of an object instance on the SNMP agent. So that is set request. Next to response. When sent in response to the sent message, it will contain newly set value as confirmation that the value has been the set. So that is response. Next to trap. These are the messages sent by the agent without being requested by the manager. It is sent when a fault value has occurred. So inform request, it was added by SNMP PV2C used to determine if the manager has received the trap message or not. So these are the 5 to 7 SNMP message: get request to get next request to set request to response to trap and inform request. Next, what are the security levels of SNMP here? So here these are the 3 security levels of simple network management protocol. So the first one is no authorization and no privacy. So no authorization and no privacy. No authorization, no privacy stands for the security levels uses a community string in order to predict no authorization and no privacy. So it is security level uses a community string for authorization and no inscription for privacy. So this is the first security level. Next to authorization, no privacy. Here it uses a HMAC with MD5 authentication and no inscription is used for privacy. This is the second one. Next to authorization and privacy. So here it uses HMAC with MD5 and SHA authentication and encryption uses for DES 56 algorithm. So by using that DES 56 algorithm, the security level, authentication and privacy can stand. So these are the 3 security levels of SNMP: no authorization, no privacy; authorization, no privacy; authentication, no privacy; authentication and privacy. So these are the 3 security levels of SNMP. Next, what are the limitations of simple network management protocol? It is very, very important. Here, 7 types of limitations of SNMP here. The first one, configuration validation. What is configuration validation? It should be possible to validate configurations only. So in before connecting, so in order to configure first, before connect, it can be configured. After configuration, it can authenticate, connect to the device. As to configuration database schemes, so there is a need for a standardized configuration database schemas or data models across the operations. So this is about configuration database schemas. Next, to comparing configurations here, devices should not be arbitrarily recorded data, so that it is possible to use text processing tools such as difference to compare configurations. Next, to role-based access control here, devices should support role-based control model, so that a user is given the minimum access necessary to perform a required task. Next, consistency of access control list here. It should be possible to consistency checks of access control list across the devices. Multiple configurations. It is for single. It is for multiple configurations. And the last one, support for both data oriented and task oriented access control. So here it can be bidirectional performance. So here data oriented and task oriented access control, while the SNMP access control is data oriented. The CLI access control is usually task oriented. There should be support for both types of access control. So these are the 7 types of limitations of simple network management protocol: configuration validation, configuration database schemas, comparing configurations, role-based access control, consistency of access control list, multiple configuration sets, support for both bidirectional data oriented and task oriented access control. It can perform the both data oriented or task oriented access control. So these are limitations. Next, versions. We have different versions of simple network management protocol: SNMP V1, SNMP V2, PV2, SNMP V3. Next, SNMP V1, V2, V3. What are the different versions? Means different upgradation from V1 to V2, V2 to V3, V3 to V4, like that. We have different versions here. The first version, SNMP V1 here, it is uses for community testing for authentication and uses UDP, user datagram protocol only. So based on the user datagram protocol, SNMP V1 is the first version of the protocol. It is described by RFC. RFC 1155 and 1157 is simple to set up. That is for first V1. There is no much of information about that. So next, V2C, it is uses community strings for communicate authentication. It is uses same UDP, but can be configured to use transmission control protocol. Improved MIB structure element. So in this, compared to V1 here, so the management information came into the force. It can describe 8 types of elements we already know, like ICMP, UDP, EGP, admission, address translation, security, like that. So here, MIB involves structure elements, transport mapping, protocol packet types are included in this updated version. However, it also makes use the current community-based SNMP P1 administrative structure, which is why the version is called RFC 1901, 1905, like that. Next, the last version is updated version. Here we are using V3 SNMP V3 here. It is a hash-based MAK. Multiple access control with MD5 or SHA for authentication and D556 for privacy. So this version of uses TCP. Therefore, the conclusion is the higher the version of SNMP, the more security it will be. So the security levels also will be Security levels also will increase in the SNMP with. different versions. RFC 1905, 1906, 2571, 2572, 2574, 2575.6 are the RFCs for SNMP v3. These are the some different versions of SNMP. So these are the advantages of SNMP here. It is simple to implement first. So there is no the physical structure of the simple network management protocol, very easy, simple to implement. Next, agents are widely implemented. Agent level of overhead is minimal. Widely implemented, the overhead is very minimal. So it is robust and extensible anywhere. So pooling approach is good for LANs based managed object. So it offers the best direct management manager agent interface. It is also made a critical need. So these are the some advantages of simple network management protocol. Next, some are the general words regarding simple network management protocol, so that we need to know what is agent, what is MIB browser, what is trap, what is variable get next management station. These already know. Agent method that monitor the devices and issues for sends alerts to the observation table. So MIB browser also we know. Trap in 5 messages also the word we discuss about trap. Next, variable. Variables are square measures the particular standing to associate object. Up and down 90% of CPU is used, etc. Get next to management station we Next to MIB community strings, management information base, that is your community string. So like passwords, see earlier in this article for more information. So get. So in order to get sends a get request to device, it monitor to receive or retrieve specific data. Notification trap B2C uh, uh, use the term notification to refer to a trap. Next to OID, object to identifier. So it is very important. So object identifier, see the beginning of the article for more information on ODA. So the object things SNMP agents gather information about, to example for the interface status or CPU utilization, polling and set. So these are the some general terms in just that may occur in the SNMP architecture. So these are the agent from agent to set. So metrics, what are the metrics we are going to measure? So here it allows various metrics from device connected to the internet. So uptime, throughput, to CPU utilization, temperature, and interface error. So what is uptime? The amount of time, how much amount of time a device has been powered on or connected to the network. So that is uptime. Next to throughput, the amount of data transferred from the source to the destination with a given time frame. So for example 12 milliseconds they can frame. So within the 12 milliseconds only the data can be transferred from the source to destination. Next to CPU utilization and memory usage. So the device performance and resource statistics, these are all comes under. Next, temperature, the current operating temperature of the device it can measure. So interface errors, so it can the list of errors that can occur during the device operation. So interface, while we are in interface the devices, then at the time of the interface errors are may come. These are the some metrics of SNMP. Next, the last one, a need for SNMP is in network management here. So the need centralized in order to maintain the centralized monitoring and control. Next, to rapid fault detection and troubleshooting. So here, in order to detect the errors while we're transmitting the information and troubleshooting problems also it can detect. Next, efficient resource utilization. So it facilitates resource optimization by providing insights into network utilization, bandwidth consumption, and device performance. So these are the three needs of simple network management protocol in network management. The first one, in order to maintain this centralized monitoring. Centralized monitoring means compulsory. There is no need of failure of the systems, or there is no lack of information from the transmitter to receiver like that. This activity can be provided by the centralized monitoring system. So that's why then this is the one of the need centralized monitoring and control system, and fault detection and compulsory we have to detect and we have to solve the troubleshooting problems also. Next to efficient resource utilization. So these are the needs. Next, trend analysis and capacity planning. Trend analysis and data gathering capability extend to monitor and long-term trends in the network usage, and proactive security management. So security breaches the unauthorized access can be devastated to the network. So it can unauthorized persons are very used in the network. Compulsory the network may be collapsed. So here remote configuration and management. So you can operate with anywhere, not to wide communication, so you can use wireless communication. It's scalability and complex management in order to increase the scalability of the system. The network grow in size and complexity, manual management becomes increasingly challenging. So these are the remaining needs of SNMP in network management: trend analysis and capacity planning, proactive security management, remote configuration and management, scalability and complexity management. Next, these are the some references I referred for this lecture here. Geek for Weeks, JavaPine.com, Motodata.com, Phonics.com, Prebytes.com. So these are the some references here. So remaining continue with next class. Thank you.
Like, share, and subscribe. Hit the bell icon for more updates.